So we decided that we are going to multiply row 1 by 2. So we're going to have 2 times row number 1.
Would it be negative 2?
No, just 2 for right now.
Oh, okay.
Well, it could be negative 2 if you wanted to, though. Okay. So that being the case, then we're going to have what? We're going to have 6x
Minus 10
minus 10y
plus 10z
plus 10z equals a 2. Then I'd have a 5x minus 2y plus a 3z equals 0, and a 7x minus y plus a 3z equals a 0. Okay, so what we have created here is an equivalent system. So this is an equivalent system that's equal to the one above. That's why we're allowed to do all these moves. All right, so now Theo said that he wants to do -1 times row 1 and then add that, or sorry, -1 times row 2 and add that to row 1. So that's going to be our next move, okay? So we're going to go -1 times row 2 and add that to row number 1. And that's going to be our new row number 1. Okay, so doing this move, let's do it together, make sure we're not making any mistakes. So -1 times 5, how much? So -5x, right? -5x plus 6x, how much?
1.
Just 1x, very good. Okay, -1 times -2y. Positive 2y. Positive 2y minus 10y? -8y. Good. -8y. Good. Okay, -1 times 3z.
Positive 7z.
That'd be a -3z plus 10z.
7z.
Positive 7z. Good. Equals on the other side? 2. Very good. And then I would still have a 5x, a -2y, a positive 3z, a 0, a 7x, a -y, a positive 3z, and a 0. All right. We're looking for our next move. What's it going to be? Now that we have a 1 in our leading coefficient for our x, we need to get zeros below them. So we can actually get 2 for 1 out of this one, right? What if I did this? What if I did -5 times row 1 and added that to row 2? Would that get rid of that? Would that give me a 0 there in that spot? Can I do the same trick for row 3?
Yeah.
What would it be, though?
Negative 2.
-7 times row 1, then add that to row 3. So there's going to be my new, that's my new map, right? On the right-hand side there, that's my map of what I'm going to do. So does my top row stay the same, you guys?
Yes.
Yeah, it sure does, right? Okay, I'm going to get 0 here by design and 0 there by design. We're designing it that way to get that. So let's see here. Let's do a -5 times a -8y. What would that give me? Positive 40y, right? Positive 40y minus 2y, what would that give me?
Positive 3.
Yeah, positive 38y. All right, good. Let's do a -5 times a 7z. What would that give us? -35z plus 3,
So negative 32.
-32z. Equals on the other side, -10 plus 0. Is that just -10?
Yeah.
All right, good. Now let's do -7 times row 1 and then add that to row number 3. So -7 times -8,
Negative 56. Or 50.
positive
56.
56 minus 1.
55.
Good. So 55y, good. -7 times positive 7z. -49 plus 3.
44.
-46z, good. Equals on the other side. -7 times 2. -14 plus 0, just -14. What's our next step going to be? Now that I've moved this up here, what do we want? What are we trying to achieve? Well, we want to get we want to get like a z essentially by itself, right? So normally we would want to get a 1 in where my 38y is and then 0 below that. So here's what we're going to do. Okay, I'm going to do something tricky here. I'm going to multiply row 2 by 55. 55 row 2. And I'm going to multiply row 3 by a -38 times row 3. Why would I do that? Yes, Annie, what do you see?
Because the y's would become about the same number.
Good, then the y's would become the same number but with opposite signs, right? Okay, so we're gonna need calculators out for those of you who don't have one. So we're gonna have x minus 8y plus 7z equals 2. Then I don't need to write anything down there. What's 55 times 38? 2090y. Good. What's 55 times negative 32?
Negative 1,760.
Good. What's that's gonna be negative 550, huh? Okay, good. Now let's do negative 38 times row 3. Well, I'd have 0 there before, and then this is gonna be a negative 2090y. What's negative 38 times a negative 46?
1,826. 24.
Well, I'm getting 1,748. Can someone check that for me?
38 times 46.
Yeah. And then let's do negative 14 times negative 38. $532? Can someone verify that for me?
Yeah.
Good. Okay, awesome. Now that we have this, right? What is our next move going to be?
Minus subtract. Or actually add.
Yeah, we're going to go 1 times row 2 plus row 3. And actually, I should have written that down here. That's where that goes, okay? So top stays the same. Top stays as x minus 8y plus 7z equals 2. This is 2090y minus 1760 z equals negative 550. Then look, I get a 0 there, right? And then what's negative 1760z plus 1748z? Negative 12z, negative 550 plus 532. I got negative 18.
Can get Z.
Yeah, check it out, right? I can see there that I can see that. Ooh, negative 12z must be negative 18. Ooh, that's good news, right? Negative 12z must equal negative 18. That's what that line of algebra says, right? So therefore, z must be negative 18 divided by negative 12, or 3/2. So z has to be 3/2. And remember, the whole goal of this thing is to get x, y, and z. Well, now we have one of those values, right? We know z is positive 3/2. Awesome. Now that I know z is 3/2, I'm going to begin to back substitute all the way up the chain. This is why it's important to put your system into row echelon form, because notice that if we did not eliminate that x variable from row number 2, we would have still 2 variables to deal with, and we could not be able to solve for one individually. So now that we know that z is 3/2, we can substitute back and say this: 2090y minus 1760 times 3/2 has to equal negative 550. Go ahead and solve for y for me. So I had some algebra done, and we had 5 people in the room verify that y has to now be a 1. All right, good. So if z is 3/2 and y is 1, then we can go back up to this equation, row number 1, and solve for x. So we would have this: x minus 8 times 1 plus 7 times 3/2 has to equal 2. Can you now please tell me, what does x have to be? So I had like 4 people say that x is now negative 1/2. So therefore our solution, right, is, remember, our solution is the ordered pair x, comma, y, comma, z. So in this case, it's going to be negative 1/2, comma, y was a value of 1, comma, z is a value of 3/2. So that right there, ladies and gentlemen, is our answer. So look at that. Look at all the areas there are to make a mistake, right? Tons of areas, tons of opportunity to make a mistake. So your goal as you're doing this is to not make a mistake as you go, because you're going to get very frustrated along the way, okay? Okay, so we have this wonderful system here, and we're trying to solve it. And is it in row echelon form? Kind of. Better than the last one. Yeah, all right. We have a 1. We have a leading coefficient, the 1 on our x term. So what's our next goal then to get?
To get the last, the second.
The other two rows.
We want to get zeros below underneath that column there. So we're going to do -2 times row 1 plus row 2. And then how do we take care of that third x in that third row there? What should we do?
Times by -1.
Yeah, do -1 times row 1 plus row 3. Okay? So far, so good? So top row stays where it is. So x minus 3y plus z equals 1. This is going to be 0 by design. That's going to be 0 by design. Okay, here we go. What's the -2 times a -3y? Positive 6y minus y is what? Positive 5y?
Yeah.
Okay, good. -2 times z. -2z minus 2z. -4z. Good. Equals -2 times 1. -2 plus 2. 0. Very good. Okay, let's do the next one. -1 times a -3y. 3y. 5y. Good. Okay. Good. -1 times z. -z minus 3z. -4z equals -1 times 1. -1 times 1. -1 minus a 1. -1 minus 1.
-1.
-2. Let's not forget our basic addition skills, okay? All right, we're doing pretty good so far. Some of you might see something interesting, but we're doing good so far. Okay, what's our next move going to be?
Row 2, or negative row.
Row 2 plus row 1. Or row 2 plus row 3.
Row 2 plus row 3. Row 2 plus row 3. Okay.
Negative row 2.
What do you want to do?
Negative row 2.
-1 times row 2?
Yeah.
Okay, you want to do that? I'll do that with you. Okay, -1 times row 2?
Not exactly.
Yeah, it does.
It works.
Yeah, it does.
Ooh, we're discussing about what to do.
Saying here is 0
Yeah,
is
you'll still
equal
get-
to -2,
So
which
no
is
No,
Oh, wait,
No, you'll get it.
What happens if we just do this?
Then we cancel out the.
Let's do 1 times row 2 and add row 3. Let's just go ahead and do that. That was our original thought, right? So we have x minus 3y plus z equals 1. Then I'm going to get 5y minus 4z equals 0. Then if I add that together, I get 0. Add that together, what do I get?
you don't get 0.
You get 10.
Oh, sorry, excuse me, 10, I mean. 10y. Okay.
Minus 8y. Wait, 8z.
Is this what you guys wanted to do?
Why are we?
Because I added row 1 and row 2 together.
Yeah, but what's the point of
So do you want to make it negative then?
-1?
Ah, okay, so make it negative, okay. So then make this a -1, is that what you want to do? Okay. So what would that give me then?
Give you
0.
0.
They give me 0, right? 0 plus 0 equals -2. Okay, ladies and gentlemen, check it out. When does 0 equal -2? It never does, okay? So this implies a false statement. Do you guys agree with that? Okay, if you have a false statement, that implies that you have no solution, which means you have an inconsistent system. And you don't need to go any further. That's pretty nice. All right, so we have the system down here. What do we want to do first? What's our first move?
Add row 1 to row 2. Sorry, row 1 to row 3.
Yeah, row 1 plus row 3. Let's add these together, okay? That's a good call. I'm going with that. So we're going to say x plus y minus 3z equals -1. Y minus z equals 0. Then if I add those together, I get 0 by design there. So then this looks like 3y minus 3z equals 0. Is that what you guys have? All right, good. What's our next move?
-3 or negative row 2 or -3 row 2.
Negative 3 times row 2, and then add that to row 3. Good. Cool. So that's going to give me x plus y minus 3z equals -1. I get y minus z equals 0. Okay, now -3 times row 2, add that to row 3. Well, I get 0 here for sure, right? Okay, -3 times the negative z is a positive 3z.
But now you get 0.
So positive 3z minus, 0, right? Okay. On the other side, 0. Oh, check this out. What is this? Is that true or false? That's a true statement. All right, so if we have a true statement, that implies that we have infinitely many solutions. Okay, if that's your case, then you have to represent it in a different way. And what that means is you have to write it in terms of A. So when you see this, you want to write in terms of A. So what do I mean by that? Okay, so we're going to let one of the variables, I'm going to let z equal A in this case. Okay, z is going to equal A, since that's the one that I was trying to solve for at the very end there. So if z equals A, then if I use some back substitution, here's what I get. I get y minus A equals 0. So that means that y is also equal to A. So using back substitution again into the first row, I get this. X plus A minus 3A equals -1. Well, that means that x minus 2A equals -1, so x must be 2A minus 1. So therefore, if there are infinitely many solutions, well, then the only thing that we care about is the relationship between x, y, and z, not necessarily x, y, and z, the values themselves, because there's infinitely many. So therefore, our solution, it will look something like this. Remember, we're still having the x, the y, and the z, but we said that z was a value of A. Turns out that y was also a value of A, and that makes x a value of 2A minus 1. So if I told you, okay, guys, if z is 3, then y has to be 3, and then x would have to be 5, right? So the relationship between them is what we care about, not necessarily what the values are, because there's an infinite order to them. All right, so yes, it's true that that's a long, tedious process. And yes, it's true that humans are not very good at long, tedious processes. That's why we come up with computer programs to help them do them for us. So that being said, if you think about it, there's really only 3 rules that we've applied, right? Those 3 for those row operations. So can't you just keep applying those row operations until you get it to a certain form that you want it? Well, that's called an algorithm, right? And algorithms are, of course, what computer scientists use all the time to write code so that we don't have to do it for ourselves. Okay, now, me being your teacher, I need to teach you both ways. You have to know how to do it by hand, and you also have to know how to use the calculator. I need you to do both. So now here's the fun part. This over here, this multivariable linear system, you see how it has an x column, a y column, a z column, and an answer column, right? So we have columns that go up and down. We have these rows here, right? Well, it turns out rows and columns are arrays of numbers or matrices, all right? So a matrix is nothing more than an array of rows and columns put together in a certain way. Your calculator can do cool stuff with matrices. So here's how you enter a matrix on your calculator. Turn it on. Right? And then go second matrix, which is the 4th button down on the left. Everybody cool? Yeah? All right, now, see how you have a couple of tabs here? You can have names, you have some math, and then you have edit. So I want you to go over to edit. All right? And you can edit matrix 1, matrix 2, matrix 3, matrix 4, blah, blah, blah. They have these names. The default names are A, B, C, D, and yada, yada, yada. So we're going to go ahead and edit matrix number 1 by pushing enter. So if you have a fancy schmancy calculator, you have just rows, you have just like boxes you're going to fill in. But for me, this is what I see. All right. Now, matrix A, you have to tell the dimensions of matrix A. The dimensions always go row by column. So there are 3 rows, row 1, row 2, row 3. And there are 4 columns, the X, the Y, the Z, and the answer column. So when you push 3, enter, 4, enter, you tell the calculator the dimensions of the matrix you'd like to enter. And then for us, we're going to enter these values in. So check this out. See down here on the screen it says 1, 1. That means row 1, column 1, and then the entry. So I want that to be a 3 because it says 3 right there. So push 3, and then enter, and notice it makes it a 3 in the calculator. And then it automatically moves you over into the second column. Same row though, right? So I'm going to go -5. So push the negative, not the minus sign. -5, enter, boom. 5, enter, boom. And then it moves me over to the last row, or last column, and I'm going to push 1, enter. Then it brings you down to row number 2. So there we go. 5, enter, -2, enter, 3, enter, 0, enter. Finally, row number 3. I want everyone to do this. Follow along right now. 7, enter, -1, enter, 3, enter, 0, enter. All right, did I get all those in there right? All right, looks pretty good to me. If you don't enter it right, it blows the whole thing out of the water. Okay, you guys cool so far? Good. Now that our matrix is in our calculator, you can hit second quit, which is second, the yellow button, and then mode. And when you go back to matrix, second matrix, notice that it's stored in there for you. All right, your 3x4 matrix is entered in the calculator for you. We want to do some math with this though. So we're going to go over to the math button. And you have some options. You have DET, which stands for determinant. You have T, you've got the dimension. You got all kinds of fun things going on here, right? But we want to go down to, oh, this looks fun. Ooh, REF. Check that out, REF. And then there's another option, which is RREF. We're going to explore both of these right now. REF, what do you think that stands for? Row echelon form. Oh, yes, indeed. So we're going to push enter, and notice our main screen, push enter when you're on that, gives us our REF. Now, the calculator says row echelon form of what? Well, you got to tell it the row echelon form of the matrix that I just entered. So I have to go second matrix, and notice that my highlighter is on matrix number A, or letter A. So by pushing enter 1 time, it puts it on there for me. So now, check this out. Don't push enter yet. Everybody have row echelon form, then matrix A? Is everyone with me? Say yes. Say something. Yeah. Good. Okay, good. So then when you push enter, you get all kinds of stuff going on here. You get a bunch of decimals, right? And notice that it's kind of hard to see off the screen. Now, notice how these decimals are here, and it's kind of like funky. And then if you scroll over to the right, you can see the other answers, you know? But I don't like that because it's in decimal form. So your calculator is also cool enough to give you a fraction form by doing this. Math fraction is your first option. By pushing enter once, it says, hey, put my answer in fraction form. Bam. There it is. Fraction form. So it's underneath the math button, which is the 3rd button down. Now, you guys, what are we interpreting here? Look at this. Notice how we have row echelon form. We have a 1. That stands for our x, and then we have a 0 below that. Then we have, okay, we have a 1 for our x here. It's our leading coefficient. Zeros are below that. We have a 1 in our y column position with a 0 below that. And then we have a 1 in our z. If you move over, check it out. It says that 1z is equal to 3/2. And isn't that what we came up with for our z answer for our very first one? So what we interpret here is that, here's what we see. We see that 1z is equal to 3/2. So now we have the answer of z. But you know what? Wouldn't it be cool if we could get all the answers at once? X, y, and z. That would be cool. Well, that's what RREF means. That means reduced row echelon form. So check this out. We're going to go second matrix. We're going to go over to math. And we're going to go all the way down, I think it's option number B. RREF, row reduced echelon form. Push enter brings you back to the main screen. Then we're going to hit second matrix and tell it which matrix you want to reduce to row echelon form in. And then one's already highlighted. Push enter again, and there you have all your answers that we came up with. Now I can turn this into a fraction form by going math, frac, and then here's what we have. Check this out. This says that 1x is equal to negative 1/2. This says that if I read it across, 1y is equal to 1, and 1z is equal to 3/2. And if you'll notice, that's exactly what we came up with as our answer down here. There it is right there. So check it out. 1x is negative 1/2, 1y is a 1, and 1z is 3/2.
So if we do this on the calculator, do we have to show it?
Okay, the question that every student has. Well, now that I can do the calculator, I have to show the work. And the answer is yes. You have to show the work, okay?
This is just a check if